This lesson begins our discussion on loops, the last of our three programming structures: sequence, selection, and iteration, which is another name for loops. So here's the basic problem. You want to display the message "Welcome to Java" 100 or 1,000 times on the screen. How are you going to go about doing that with what you know today? Well, with the tools we've learned up to this point in the last 5 weeks, we're left with no other choice but to type in a system.out.println and our message, and then copy and paste it 999 times, or how many ever times we would like. Now that's easy, if we have a fixed number. But what if we wanted to ask the user how many times to print "Welcome to Java"? Well, we're out of luck. Unless we learn some new tricks. Copy and pasting a number of sysout.printlns is not going to work. Loops. That's the new tool we need to learn. We begin by discussing the while loop. This presents us with the basic structure and understanding of loops. Then we'll move on to do loops and for loops. Both have unique characteristics that we need to understand, so we know when to use which one. While, do, for loops. These are the last of the three programming structures: sequence, selection, and iteration. So the graphic up there shows a very basic loop. We'll discuss that a little bit more in the next slide. But what about that problem I posed earlier? How would you change that first example to display the message only the number of times requested by the user? Now stop the video and think about how you would do this. Did you come up with this solution? So the difference in the two loops is basically in the Boolean expression that follows the while. In the loop 1, the count's compared to less than 100. And in loop 2, count is compared to being less than the number of times the user has entered. So pretty easy fix. Well, looking at where we're going might be a little intimidating, especially if you think this video is going to be too long. We're going to start with the while loop, and we will look at a program to guess a number, right? And then we'll kind of follow up with some strategies, and we'll talk about counter-controlled loops and Sentinel loops, and then we'll look at an alternative way of getting input from a file called redirection. Right? So we'll concentrate on the while loop so we get a good grasp of loops. The next lesson for Wednesday will cover the other forms of loops. Okay, a few caveats. Caveats are things to remember. Since this lesson deals with only the while loop, these caveats are true for the other forms of loops that we will experience. Okay? So the execution of the statements in a loop body, they're controlled by Boolean expressions that reside inside a parenthesis, much the same way we had Boolean expressions inside parenthesis when we did selection statements. Right? One of the things that you want to avoid is using doubles and floats in our equality tests as part of our loop continuation condition. The reason is because those numbers are not very precise. In most cases, the loop body will continue to execute as long as the Boolean expression in the loop continuation condition is true. Okay? Now, what follows from that statement is that something in our loop body must occur in order to set the controlling Boolean expression to false. Well, if something doesn't happen in that loop body to set the condition to false, our program will continue to execute the instructions in the loop body forever, known as an infinite loop. Most of the time, you can manually stop your program from an infinite loop and break out of the loop by pressing the Control and C key together. That's called the break key. When I reference the loop body, that's the same as we mentioned code block earlier. The loop body or control block, code block is contained in braces. Okay, here's a while loop. We just see the general structure of a while loop on the left, and then we see a little snippet of code that's going to print our little welcome message 100 times. What I want you to do is really kind of see the similarity with our if statement. Mentally replace the word while with if. The difference would simply be that the loop body would only be executed once with an if statement. This while loop structure is known as a pretest loop. Why? Well, if we look at the flow chart, the Boolean expression controlling execution is tested before any of the statements in the loop body are executed. So note that when the expression controlling the loop execution becomes false, the loop is no longer executed and the program continues with the first statement after the loop body. So remember, the intent of our snippet there is to print our welcome message 100 times. Study it a little bit, convince yourself that it will do it. Remember, I just said a while loop was a pretest loop. Well, look at the code on the right. For whatever reason, the programmer decided to set the count to 100. So once the while statement is reached in the program, the controlling expression will test false. The loop body will be skipped, and execution will continue with the statements following the loop body. So one of the characteristics of a pretest loop is the loop body may be executed 0 or more times, depending on the condition of the program, before the loop Boolean expression controlling the loop is reached. We'll see in later lessons loop constructs that will assure us that the code body is executed at least one time. But for now, while loops execute 0 or more times depending on the condition of the program when the while is encountered. Well, look again at the code on the right. Determine how this loop will perform. Did you see the problem? Yep, we're going to have a loop-to-loop. The problem is nothing occurred in the loop body to change the value of count. So count remained 0, and every time the loop went back to test, count was less than 100. Well, in the previous slide we saw how not changing the loop control variable can cause an infinite loop. Take a minute and look at example 1. Does it accomplish the intent of the program snippet to display the message 100 times? Stop the video for a second. Did you determine the error? The loop in example 1 will display the message 101 times. This is called the one-off error. Remember that count is starting at 0. So after count has reached 99, it has printed the message 100 times. And as I add 1 to count at 99, it's still equal to 100, so it'll execute the loop one more time. So you kind of have to watch your loops, especially when they're counter controlled like this, to make sure you don't have a one-off error. Alright, what about example 2 here? Is there anything wrong? Well, the Boolean expression is simply wrong. The loop will not execute because count is 0. And we're saying, well, only to execute the loop while count is greater than 100. Okay, let's watch a little animation of a while loop. The program is setting a precondition by initializing count to 0. Whenever you're using a count of some type to control our loop execution, we call our loop a counter-controlled loop. So the first thing that happens is we test our control variable, count, and to see if it's less than 2. Since this is the first time we've encountered the while, count is 0, so our condition is true, and the code will, in the body of the loop, will be executed. Well, the first statement in our body is executed. So we should make note that there's no limit to the number of statements a loop body can have. Pay attention that the body is set off by the braces. There's also no restriction as to what kind of statements can be used in a loop body. So we can find all of the programming structures we've talked about: sequence, selection, looping. Yes, we can have loops within loops in our loop body, called nested loops. We'll study those in a lesson or two. All right, next the count statement is executed, and it increases our count by 1. So once we've reached the end of our loop body, denoted by the closing brace, we'll return to our controlling expression and test once again. So the sequence for a while loop is, let's test our condition. If it's true, we'll execute the body, and then we'll return to test again. And remember, something has to happen in the body to make our Boolean expression false. In this counter control loop, the count plus plus adds 1 every time the loop is executed. So we are changing the value of count, and hopefully our loop will stop. Well, this is the second time we're going through our loop body. We went through at the beginning when count was 0. We added 1 to count. Count is now 1, and so we're going through the second time. Well, 1 more is added to count, and its value now is 2, and the loop will return to the top to test once again. Well, here we are at the top. Our condition is no longer true. Count is equal to 2. It's not less than 2, and so we will not execute the. Well, we skipped the body of the loop, and now we are at the statements that follow the body, and program execution will continue there. So loops take a little planning. You have to first of all determine which statements from your pseudocode need repeating, and then as you are coding, enclose those statements in a loop, and maybe just use the while true as the starting condition. Once we have the statements written, then we can go back and look at coding the Boolean expression that is going to control the execution of our loop. So just kind of plan which statements, right, do I need to execute more than one time. Okay, let's look at a little pseudocode for the guess number program on page 119. The first thing we have to do is generate a random number between 0 and 100. Once we've generated that number, we ask the user to enter a guess, and if the guess is equal, we'll tell the user that they've won, and we'll exit the program. Otherwise, if the number is not equal, we'll tell them whether the guess is too high or too low, and then we'll return to step 2. Ask them to enter another number. Looks pretty straightforward. So the pseudocode in the yellow is what needs to be enclosed in a loop. So let's take a look at the program. You can follow along on the screen, or the program is in your book on page 119. It's also available for download from Blackboard in the content area. Statement 6 generates our random number. Remember, random generates a number that is greater than or equal to 0 and less than 1. So then the statement multiplies that by 101 and casts its added integer. Why multiply by 101 and not 100? Well, if I multiply by 100, the largest integer I can get is 99. So using 101 assures me that it's possible to get 100 as an integer. Statement 11 is initializing my loop control variable, guess, to a precondition of -1. That way the loop condition will test true for the start. Now statements 12 through 23 are my loop, and my loop control expression is that guess is not equal to number. Number is what I had generated as random. And since guess is -1 to start, the condition is true, and we'll begin executing the loop body. 14 and 15 prompt the user to get input. Line 15 continues every time through the loop to change the value of guess, which we hope will sooner or later equal number, unless the user is very computer phobic, and sooner or later they'll get tired and or else get it right, and so then our loop will end. Lines 17 and 19 test to see if guess is equal, or if it's too high or too low. Line 23 will return back to line 12, where guess will be tested again, and if guess is equal to the number, the loop will not be executed, and our program will continue to line 24, which in this case is the end of the main method, and by the way, the program. Note that line 24 and so on could have continued Java statements. It's just that this program didn't require any. Let's take a little closer look at the loop initiated at line 12. Earlier we saw a counter-controlled loop. However, this doesn't quite look like that. our control variable is guess, and in the loop body its value is being changed by the user's input, not by adding 1 to it, like we did with a counter-controlled loop. So our Boolean expression, guess not equal 1, is on the lookout for guess to be equal to number, because then my condition will be false. In the military, the guards who guard the fort are on the lookout for some suspicious activity, and they're called sentinels. Well, in this case of our loop, starting on line 12, we call this a sentinel-controlled loop. We can't predict how many times the loop will execute, but we simply need to be on the lookout for the user entering the right answer. Now, many loops are sentinel-controlled, so we're looking for some condition to occur. Listing 4.4 on page 123 is another example of a sentinel-controlled loop. The program will continue to add numbers until 0 is entered. The loop is defined on lines 16 through 24. Lines 10 through 12 are needed to get an initial value for data. I call this a priming read. Just as you need to prime an old-fashioned water pump with a little water to get it to work, see the priming video, we need some data to start our program running. Notice also that statements 20 through 22 are inside the loop, and we're asking the user to enter another number, and once we read that number, the loop will return to line 16 and test its value. This same program is available for download, and it is also an example that we use in the next couple of slides about redirection. Well, by redirection, we mean that we can direct our program to look for input from a file, or to record the output to a file instead of the standard in device, the keyboard, or the standard output device, the display. So we're redirecting the program to read from the keyboard and we'll read from the file. Okay. So what we want to do is be careful on using redirection, because if you're redirecting output, don't expect your users to see any prompts. And if you're redirecting input, don't expect your users to be entering anything from the keyboard. This is kind of a handy device, especially if we have a large number of numbers or data to enter. We could enter them in a text file prepared by Notepad or something similar, and then use that as our so-called maybe pseudo keyboard. Okay, it's important that if you're redirecting input, that the file be a plain text file. If we're looking for numbers, we would enter those much the same way we would on a display, by putting a space between each number we want entered, or entering each number simply on a line by itself. The output is also a text file, so it's easily read and opened by Notepad. Well, this simple redirection can only be done at the command line. There's no easy way to tell TextPad or to tell NetBeans to read from a file in sense of using redirection. So if we're running at the command line, we need to be navigated to the folder where our class and our .java files exist. All right, and it's probably best that if you're redirecting input, that your input file be in that same folder. Just makes it a little simpler. Okay, we can see that the less than and the greater than signs are used for redirection. Right? So there's 3 examples up there. One simply redirecting input, another redirecting output, and then the final example is that we can redirect both input and output. I challenge you to download the Sentinel value program and give redirection a try. Well, that's it for introduction to loops using the while loop. The next lessons we'll start talking about the do loop and the for loop. We'll look at nested loops and make you aware of some of the common errors that you should try to avoid when working with loops. We talked about a few of them in this lesson. So I hope this hasn't been too boring.